Yes. Six, six. So I'm ready. Do you want me to continue on the lab so you can actually leave earlier? Or do you want me to stay all the way to 7, then start?
I'm
Now
fine
is
to
good.
start now.
Okay, I think it's better because the lab, we don't have that much actually stuff for the lab, and hopefully it should be easy for tonight, and hopefully you can enjoy this part that I'm showing some pictures from that your friend did in the past, that there was no corona. Okay, so let's go. So we are done for those group that they worked on this lab for Tuesday. Last week, I gave you the last part of the lab for your report. So this part is the real lab that we did on the past, and you can see the results this week and next week. So this is the sample beam that we ask your friend to actually work on it. As you can see, 5 inches by 6 inches, very a small beam. F''C 4000, FY 6000, and FYT for the stirrup was almost 60,000 again. And D we consider 5 inches, and D prime 1 inch on top, 1 inch at the bottom. So, and that's the cross section that we use for the real beam. Then for the form, they have to build the form. That's, you can see that these are the size, because when you pour concrete, it will push this outside. So this vertical cannot tolerate the load. So even for a small amount of the concrete, the pressure is high for this form. So we have to connect them on top to be able to hold this like the bottom. Yeah, we connect these to the bottom on the top too. So that's the different actually pictures that start shows the from a start almost to the end of this form that your past they did that. So as you can see, we connect the top together. So at 3 points, those are not for holding this because it's heavy. No, those are just for keeping the form at the location that we want. Otherwise, as soon as you pour the concrete, it cannot tolerate the load. We have to connect them to each other. I named them for our group because we have 2 different classes. So for my group, I call them A1, A2, all the way to the end. And the other group, I'm not sure what they call B1, B2, all the way to B6. We had 6 groups, 3 and 3. So these are the forms. And after I actually started working on reinforced concrete design, they just use this and they threw them away. I stopped them and I said, no, we can keep them. And these are very good plywood, and we have to cut trees to just build this stuff and then throw them and use the new one. Why? So we started just unscrew this after the pour and removing the beams, and then put them back again. And as you can see, it's used already. All of them are used, and we are using them again. And they are ready for last semester plus this semester that we didn't use them. So they are still there and waiting for one day that we can start working on. So these are the rebar that I ordered, and they bent them for us because we cannot do this. These are the small stirrups, as you can see, for 5 inches beam. Those are the compression bars and tension bars. You can see, and these are the premix cement. And this is the system that we are using for breaking the concrete. I have all the pictures from those as well. And these are the for supporting at the bottom. But these doors were not that good. Those are big. They sent us and the wrong one. We want 1 inch, less than 1 inch, but they sent 2.5 inch for regular work. That's not good for us, and we didn't use them, but we have them there. These are the process for connecting the rebar. As you can see, bottom rebar plus the stirrups, they are connecting, and it's hard. Yeah, and each iron worker should tie rebar 1,000 pounds per day at least. And over here we had 5 people, and those 5 for connecting this rebar for 3 or 4 hours. Barely they could get that done. Yeah, and the total weight was less than 50 pounds. Yeah, and just imagine one guy, one day, 1,000 pounds. That's hard work. And when they start tying them together, they understood that what hard this job is. That's very hard, and you should know. Otherwise, you can cut your fingers. It's very easy to damage your hand. So these are the process that they did, and from close picture, those are the tie bars that they tie the main bar to the stirrups. Yeah, and these are the 100-degree, 135-degree bend. It's not 180, 135. It means that 45-degree for to other side. So, and then when they complete, as you can see, top bars and bottom bars, yeah, both of them, and they put them with some spacer at the bottom. We can see that here. Those are plastic one that we actually bought from somewhere, and they installed it inside the box, and it's ready for concrete placement. So this is rebar cage inside the box, is ready for concrete placement, and this is just a rebar cage that we have. And actually, I missed all this stuff. Yeah, we had a actually very good days on those that everybody could talk, and they actually had fun, and also working on this stuff and learn. And so that's a very good practice. Unfortunately, we missed those opportunity. And this is the concrete placement. As you can see, they mix the concrete, they put them in cylinder for the brakes, and also they put them there. And with the rod, they actually did the kind of vibration. Instead of vibration, just we use that rod for tapping inside the form and inside this in 3 layers. Exactly the same as, and the name on the cylinders, everything exactly based on what I mentioned during these classes. And then for curing, when they made that completely smooth, they put something and on the backside, outside of the lab. They set those over there. Each one with 2 is for 5 students. If we have 15 in each actually lab, so 1 beam plus 2, one group, 1 beam plus 2 for another group. So these are for curing up to 28 days. And then after this, they brought this in the lab to break them. So this week, I gave you this information, what they did. And next week, I'm showing you the pictures of the breaking the beams and the cylinders and the results of the broken beam. Those are interesting picture, and I'm glad that I took those pictures. Just I thought maybe it's better to take those pictures, and later I saw we can use them at least here to show the difference between lack of the syrups or lack of the tension bars. You can see them on the next actually class for lab. So thank you so much. This is that's it for the lab part tonight. If you have any question, please let me know.
So, Professor, one of the molds had no had no stirrups, and one had no tension bar. Is that what you said?
So now I gave different actually beams for different groups. I gave them compression bar or top or without compression bar. For some another group because we had 6 groups. So I tried different cases so they could see different actually results from breaking the beams. So some of them very far, one with no syrups, and because of they could see different results of breaking those beams.
Okay, I see. Thanks.
Any other question? Okay.
For the sorry,
Sure.
Can I ask just a quick question for the
Sure.
curing one? So
Yeah.
like the only like curing I've done on campus is like like little cylinders in the materials lab, and so we put them in the like the like it's like underwater or whatever. So is there it's like underwater somehow? Is there like water in there?
No, actually, that's a good question. Unfortunately, we don't have that system, and this is just for students to see these operations. But in actual system, they have to keep them in 1 day in the cylinder, then remove the cap and put them inside the water. Yeah, but over here, no. Just we cover it and we cover this with nothing else and keep this 28 days like this. So just for the cure time. For sure, it's not exactly per the code, but it's not that important. We don't want to be completely per code for this. We don't have those stuff here to do that in the lab. Just we want to show the operations, different operations to our students. But yeah, in the real work, after 1 day, they have to remove the cap and put that inside the water.
Okay, thanks.
You're welcome. Any other question?
Yeah, I have a question about lab report, Professor.
Okay.
Actually, what do you expect from us with the lab report?
Look at this. From the start day, I asked you guys to write something about all those slides that I mentioned through the past 12 weeks. And for each part, I don't want you to write 1 or 2 pages. Maybe you can write few sentences. And if you concentrate on one of those that you like the most, I like to see that. Or if everything is similar for you, just try to explain what you learned. I don't want you to go and copy and paste from somewhere. No, that's not necessary. I want to see what you learned and which part was important for you, and then put that in report with some pictures to make that clear. Consider that you are writing a report for your boss, yeah, and that's for your job. So uh, uh, please pay attention for the format that you are going to write that report. cover letter, if it has a cover sheet on top with the names and date and all, those are very important. Yeah, the pictures, the content, something like this. Do something that it's easy for anybody that can, okay, see what you wrote and the content, and then based on the content, I can go to that page and see what you wrote. And if it's clear, do you have any pictures? Something like that. Make that a good report based on what you like and what you learn. So I want to see these two parts in your report.
Thank you, sir.
Okay.
A follow-up question to that one. So we're only writing about, I believe we did like 8 different weeks so far of.
That's correct. That's
okay.
correct.
So moving forward, you're just going to be showing us like stuff like this just for
These
just like
are for
our
your
information.
knowledge. Yeah, you don't need
we didn't
to
get to
write
do
anything
it.
for
Okay.
this. Yeah, that's
okay.
correct.
Thank you.
Yeah, you're welcome. Any other question?
I have a question, but regarding the interaction diagram, so I'm not sure it's
Okay.
related to the lab.
Okay, what's your question?
Just how you set up, and then what's the condition for condition for C? Because we have to use C as a variable to plot in a diagram, and I still cannot figure out how to plot it.
Look at this. Can you remember at first I asked you to calculate CB? Yeah. And CB was easy based on the epsilon. When epsilon in concrete is 0.003 and epsilon for the rebar is Fy divided by E. Yeah. So based on that, you can calculate CB. If you look at that example, you can see. You can calculate CB, so you know CB. As soon as you have CB, you can find AB, means A. Based on A, you can find actually MU, ultimate moment capacity, and also based on the rebar, you can find PU. Is that clear? So for CB, you can find PU and MU. This part is clear for you or not?
Can you repeat again about the CB, please?
You can calculate CB based on epsilon U for the concrete and epsilon Y for steel, epsilon Y, because CB is balance point, is when your concrete will reach to epsilon U, the rebar must reach to epsilon Y at the same time. So you can call that CB, balance point. So if you look at that example, you can find this. So you have CB based on this information and that strain diagram. C is the neutral axis distance. So, and B, when it's these two are reaches at the same time to epsilon U and epsilon Y. So you can calculate CB. Based on CB times beta 1, you can find AB or A. Based on the A, you can find MU, moment capacity. And then you can calculate PU for your column. So you have 1 point, MU, PU for the balance point. Okay. For balance point, you calculate it here. This is your CB and MU. MU, PU. That's for balance point. Yeah?
Yeah.
Then for other C's, as I mentioned, over from top to here is for C greater than CB. And for the bottom is C less than CB. So for from here to here is C less than CB. That's it. So what else can you do? So go, you know this point, you find this point. You need few points for here. 1, for example, 2 and 3 points here, and 1 and 2, whatever you want, points here. Okay, how can you find this point? Pick 1C greater than CB. For example, CB is 16 inches. Go a little more than that, 17, 18, whatever you want. C equal that number. Based on that C, find A, find MU, find PU. That's 2 points for here. Then change C to another bigger number. Then find A and MU, PU. Then another number. And then C less than CB. CB was 16, go with 15 and 10, for example. Then find these two. Find these all points and connect them together. That's it. That's your interaction diagram.
All right, I'll give it a shot. Thank you, sir.
Is that clear?
Sort of. I'll figure
I
it out.
think just check the example. Follow the example, you will not get lost.
Can I ask a follow-up question on that?
Sure.
For the C, so I'm looking at the example, and it's it mentions like the E sub B as well. Like, so it says any choice of C smaller than CB, it's like the tension failure region.
That's correct.
But then it also says with eccentricity larger than E sub B. Do we need to
You
take?
don't need to do that. No.
Okay.
Because E can
just
be
like
greater than
automatically,
EB.
or?
That's automatic. That's
okay.
automatic.
Like
That's
where
correct.
it is on the.
That's
okay.
correct.
Got it.
Yes.
Thank you.
You're welcome. Any other question? Okay, so thank you for all your questions. Those are very good questions during the lecture and at this time too. So I'm done for tonight. If you have no more questions, you are ready to go. If you have questions, please ask.
Thank you.
Thank you.